Hello, and thank you for joining us today. I'm Paul Christen, and I am the Homeland Security Industry Manager here at Esri. I'm also responsible for Esri's emergency call taking and dispatch marketing efforts. Joining me today is my colleague and good friend Tyler Thompson, as well as an Esri partner and good friend Brooke Shannon from GeoComm. Today we'll be discussing how GIS supports the next generation 911. So welcome, and before we begin, I need to tell you that as an attendee, your phone has been automatically muted to avoid any background noise issues. We are recording this, and the recording will be published on our industry pages, so you can download it at a later time if you missed something or need to leave in advance of the presentation being over. So, however, feel free to ask any questions during the webinar using the questions panel in the webinar window. We will try to respond to those throughout the webinar, but also we'll review a few of the questions at the end of our session. So let's begin. First of all, many people, when they see GIS, they think of a couple of things. They think of it as a map, something similar to this, a map of the United States or a location. This one shows borders, states, cities, and roads. Some people think of GIS as a dot on the map, symbolizing something or someone, like where I work, where I live, or where I like to eat dinner, or where my favorite brew pub is. Some people think GIS is very complex, requiring special expertise or training to learn how to use it. Something like this map here, which shows lots of information, and you're just not sure how to read it because it's very confusing. It's hard to interpret. But we're going to be talking about how GIS is transforming. I'm sure all those things are true in your mind to some degree, but GIS is transforming the way we work and the way we view information, especially the way we're handling emergency call taking and dispatching. So to get into this, I want to share a personal story with you. Prior to joining Esri, I was a firefighter paramedic. So I want you to take a moment and imagine it's 1:42 a.m., you're fast asleep, and you're in a deep dream. All of a sudden, the alarm goes off in the station. The lights turn on, and you hear the speaker screaming out these words. Crystal Lake Fire Rescue General Alarm. Report of a structure fire at. You instantly jump up. You pay close attention to 30 seconds of radio traffic. And then with adrenaline pumping, you race out to the apparatus floor. You check the map hanging on the wall to get your bearings straight. You get dressed in your gear. You check to make sure all the compartment doors are closed on the engine. It's rather embarrassing to explain to the chief that you tore off a door of a $500,000 engine as you're pulling out the door. But you jump on the engine, you strap yourself in, you begin rolling into the darkness in more ways than one. So you begin to think, what am I going to find when I get there? A small kitchen fire? A large house with victims entrapped inside? Or is it a commercial structure involving hazardous materials? Will more resources be needed? Should I get them rolling now, in advance of me arriving on the scene? You're also thinking to yourself, what's the safest way to get to the scene in under 6 minutes? Are there other apparatus converging on the intersection I'm about to come upon? Are all responding units like Engine 317 approaching Crystal Lake Avenue from Route 14? These are the concerns that you have to deal with every day. In addition, what's the safest route in terms of traffic patterns, time of day? Also, where's the closest hydrant? Which is where I should lay down the hose? Where's the fire alarm panel? Where's the floor plan of the building I'm responding to? Is it single story? Is there a basement? Is it multifamily dwelling? But what if all this information was available before I arrived on the scene? And what if there was an idea of best practices and tactics beforehand? Those are the questions every firefighter asks themselves within the 4 to 6 minutes it takes to get to the scene of the fire. Many of them are not answering until arriving on the scene in the middle of all the chaos. Some of that information I just talked about is often stored in 3-ring binders, back at the station or underneath the captain's seat. A binder such as this that often flies across the dashboard as you make an immediate left turn to avoid someone pulling in front of you. Have you ever tried flipping through the pages of a 3-ring binder while riding down a bumpy road with lights and sirens blaring and try to read the Times New Roman size 12 font in the dark? It's not an easy task. But what if all that information were available before we arrived on the scene? What if the information was more easily accessible? GIS is beginning to change the way firefighters, police officers, paramedics are tackling problems as they're responding to emergency calls. Situational awareness is becoming vital to effective fireground operations and law enforcement operations. Pre-plans are accessible through GIS, provides me with the better information and of the tactics I need to take when confronted with a fire or a situation at a particular location. GIS provides instant access to pre-plans over a mobile data terminal while I'm en route to the scene, which is much easier than flipping through that 3-ring binder we talked about earlier. With GIS as an engine captain, he can prepare his crew prior to arriving on the scene. He can tell them where the closest hydrant is, where the fire alarm panel is located, where the natural gas shutoff is located, where all the doors and windows are, where are the stairs located inside so that you're not searching in the dark looking for them, and where are the rooms and hallways located at, either to the left or to the right, by looking at pre-plans information. So if we had that kind of data available to us in responding to scenes, perhaps we can avoid situations like this, converging apparatus on intersections causing accidents, or going through busy intersections more freely and clearly. Perhaps we can even save more lives, those that matter to us. But all of that starts with a call to 911, and that's what we're going to be talking about today. I'm going to turn it over now to my colleague Tyler to kind of bring to you a perspective and insight into how the GIS platform is supporting the 911 call taking.
Thank you, Paul, and thank all of you for attending the webinar today. For the GIS professionals on the call today involved in 911 addressing, I want to extend our thanks for your constant vigilance in ensuring data quality and accuracy to ensure that calls like the one Paul just showcased are responded to in the least amount of time. We all know a lot of things have to happen before that call is dispatched at 1:42 a.m. Showing on the slide in front of you right now, I'm going to talk a little bit about the ArcGIS platform. It is the platform for NextGen 911 and for public safety. As Paul mentioned, ArcGIS is transforming the way our users create and share GIS data within and outside their organization. Today, data created by GIS professionals, as well as other online sources of data, can be shared behind your firewall using Esri's portal application, or in the cloud using ArcGIS Online, making GIS data available to everyone in your organization or accessible by public users. Casual users can now create and share purpose-built maps and apps using the authoritative content prepared by GIS professionals to meet the needs of their mission or department. WebGIS enables the creation of web maps and apps accessible on any device, be it a desktop, smartphone, or tablet. What this means to public safety, and to PSAPs particularly, is the ability to do more on their own with less reliance on what are typically limited GIS resources. As we know, very few PSAPs have dedicated staff for GIS, and utilizing WebGIS enables GIS professionals to focus on the more complex needs of public safety. To illustrate this, ArcGIS enables GIS professionals to create and share rich GIS content with applications used by call takers and dispatchers. Command staff, PSAP managers, and others can now interact, visualize, and analyze call for service information in new ways versus reviewing simple tables and charts in order to make better informed decisions. The ArcGIS platform can be utilized to help educate and engage with the community through public-facing maps and apps. More importantly, the platform provides mission-critical information on any mobile device to the tip of the spear, first responders in the field who need it most. And finally, ArcGIS spatially enables data residing in an agency's records management system and other enterprise business systems, making it available across the organization. In short, ArcGIS creates an open and collaborative environment for public safety agencies. It's a major change from the way things have been done in the past. For PSAPs, it opens up new possibilities and functionality. So let's talk about a few examples what the platform can do specifically for PSAPs moving forward. And these are just examples that I put together to illustrate some concepts that will help you understand the platform a little more clearly. Let's just focus on call prioritization at this point. So here's an example of a traffic accident on a highway. in Arizona in this case. The accident has blocked both lanes. What happens in this type of incident? Many folks dial 911 from their cell phone. Inundated by these calls and the need for many agencies to answer every call on the first ring, call takers may miss this other call for service. Which is a separate incident. Using linear buffering and ArcGIS, the system can recognize that these calls in the vicinity of the traffic incident, in all likelihood, are from the same, excuse me, in all likelihood are for the same incident, thus increasing the priority to answer this separate call to the west. For reporting purposes, I know agencies that have to report every day to their chief how they did the previous day and why every call was not answered on the first ring. Well, now this can be explained visually to command staff as outliers. Although these calls near the accident were not answered on the first ring, they were for the same traffic accident and not as important as the call to the left or to the west. Here's another capability that the platform enables. Here's an example of how demographic data, such as data available on ArcGIS Online, can help route calls to the appropriate call taker. Many of the larger PSAPs use automated call distribution to route calls based on call volume, time of day, number of call takers, and other factors. In this case, according to census data, 8 out of 10 calls for this area will likely come from a Spanish-speaking caller. So wouldn't it be nice that when the call for service is routed to the PSAP, that it's also routed to a Spanish-speaking call taker? ArcGIS can enable this workflow to happen. And finally, one more example. Here's an example of how the GeoEvent processor, an extension to ArcGIS server, can help with call prioritization and alerting. In this case, it's a high school. We've put a geofence around the high school perimeter. As a call for service comes in, based on the caller location, it should and will likely receive a higher priority in the system. As the incident type for this call is entered by the call taker, for example, an active shooter situation, the GeoEvent processor can alert dispatchers, mobile users, SWAT, and command staff of this critical incident. So far, we've described how ArcGIS is transforming the way we process calls for service and dispatch resources. But let's back up further in the process and focus more on the challenges ahead in terms of next generation 911 and the work that needs to be done in order for data creation and routing of calls to the appropriate PSAP. One of our key business partners in 911 is GeoComm, an Esri Platinum business partner. With me today is Brooks Shannon, who will showcase how the ArcGIS platform can be leveraged to address current and future needs of NextGen 911. Brooks?
Thank you, Tyler. Good morning, everybody. I wanted to thank everyone again for joining us on today's webinar. Over the next few minutes, I'll discuss how GIS data works in NG911 and how it's used to get a call for service to the right PSAP as accurately and quickly as possible. So if a call for service comes in at 1:42 a.m. for a structure fire, we're getting that call to the correct PSAP as quickly as we can without any misroutes. That to me is what an NG911 is about in a really big way. Once I talk about how data is used in NG911, I'll talk about GeoComm solutions for creating and maintaining that data. I'd like to first give a brief overview of who we are at GeoComm and what our company does. GeoComm is a public safety mapping and communications company that specializes in integrating location-based technologies with mission-critical communication systems. We've been in business for 19 years. We integrate GIS with communication systems for NG911 networks, 911 dispatch centers, law, fire, and medical responders, and emergency management agencies all across the U.S. We serve over 1,000 clients across the U.S. in 43 states. While the vast majority of those clients are cities and counties, we service dozens of large regions and 8 entire states with a suite of software ranging from tactical PSAP mapping to mobile apps to GIS data management to NG911 call routing. And it's the GIS data management and 911 call routing applications that I really want to talk about today, really focusing on how we get a 911 call in NextGen 911 to the correct PSAP. 19 years ago, our company started small, but we made a big leap by installing our first PSAP mapping application in 1994, GeoLinks. As the years went on, we created additional products, like GIS data management applications for ArcMap as well as ArcGIS for server, and NG911 applications like our GeoLink Spatial Router, ECRF LVF. We have 2 deployments of that are actively routing live 911 calls today. A regional deployment in the state of Texas and a statewide deployment on the East Coast. All of those solutions leverage the ArcGIS platform for maximum integration capabilities with existing enterprise GIS systems. So I'd like to talk about the role of GIS in NG911. How does NG use GIS, and why is it so important? Why does it need to be near perfect quality, and why does it need to be updated so frequently? So let's talk briefly about what NG911 is, because a lot of folks think it's just about text messaging 911 when you have an intruder in a home, but it's much more than that. Really, NG911 at its most basic level is a major update to traditional 911 service in the United States. We're no longer talking about routing calls across analog phone switching circuits. Instead, we're talking about routing calls over IP networks. That's huge, because it means that we can develop scalable, resilient, and interoperable emergency services IP networks that support a myriad of calling devices and media types. We're not just restricted to initiating calls from a mobile phone or a landline phone anymore. We could initiate calls from an over-the-top VoIP provider like Skype. We could initiate calls from a telematics device in a vehicle. Maybe that senses a crash before callers on a freeway are able to call 911 themselves. Maybe we have a snazzy new fire smoke detector inside of a home, and that smoke detector is able to call 911 on our behalf when it senses enough smoke. Really, the possibilities are almost endless, and NG911 helps enable that. We'll also be able to support different sorts of media types like SMS texting and video, so on and so forth. But for us today, it's really all about improving call location validity prior to a call for service even being made, and call routing, making sure we can accurately route a 911 call to the right PSAP. So just to briefly set the stage and talk about a few of the acronyms that you often hear about in NG911, I want to touch on NENA's I3 architectural specification for Next Generation 911, which is sometimes referred by its document number 08003. It describes an end state NG911 architecture, which is to say that it focuses on what an NG911 system will be, not necessarily how you get there, not necessarily the transition. It defines things like an ECRF and an LVF and a SIF, which are all things that use GIS data. The ECRF is the emergency call routing function, the LVF is the location validation function, and the SIF is the spatial information function. That's the important part that lets GIS data flow into those other 2 functional elements. It's important to note that the I3 standard by itself is not the same thing as NG911, because NG911 is a little more broader in scope. It really focuses just on the functional elements and the interfaces between them that make up that technical design for an NG911 network. It doesn't focus on the detailed technical, operational, and human elements. And again, it doesn't really focus a lot on the transitional steps. So what NENA has done is developed a baseline NG911 definition to help clear up any misunderstandings about what NG911 is. It's not necessarily I3, it's more of a superset of that. These baseline definitions focus on all manners of things, from call logging and recording to geospatial call routing to being able to route calls based on policy. But for GIS practitioners like us, it's really interesting to note that 4 of 11 of these baseline definition items are focused on GIS. That's really interesting. That really shows us that GIS is central to Next Generation 911. We talk about things like the ECRF for geospatial call routing, and the LVF for authoritative location validation, as well as tools to help maintain that data, and the SIF to help provision that data, to push the data into those functional elements. So let's take a moment to talk about what the touch points are in an NG911 system in regards to GIS data. It all starts before a call is even made, with subscribers and communication service providers. When a subscriber subscribes for new service or moves to a new area and updates their address, that needs to be captured in a database of some kind. Traditionally today, that's done in an ALI database, but in Next Generation 911, we use a location information server, otherwise known as the LIS. The LIS needs to store valid locations. We don't want just any location being stored in there. So when a LIS receives a service order input, it asks an LVF, a location validation function. Is this location legitimate? Is it valid? The LVF uses GIS to make that determination and may answer yes or no. If the answer is yes, the location gets stored in the LIS, and it's ready for use in an actual emergency call. All of this stuff happens before that. Now, in the case of an actual call for service, that location that was stored in the list gets sent along with the call, and it gets sent into the emergency services IP network and is received by a routing proxy, the emergency services routing proxy. This knows how to route a call, but doesn't know where to route a call. So it has to ask something, the emergency call routing function, the ECRF, where do I send the call? The ECRF has the same GIS data that the LVF has. So it can perform analysis on that and determine that, in this example, it should get routed to PSAP A, which the ESRP dutifully does. That call then can be mapped at the PSAP. It can be distributed via ACD. Users might notice that it is not part of a cluster of calls, and maybe that means it's more important, so they can perform their prioritization efforts, as Tyler had talked about. But core to all of this is GIS. It all starts with authoritative GIS data, the creation and maintenance of that. The second step is provisioning that data into the emergency services network through the SIF, the spatial information function, in an initial and an ongoing way, provisioning that master GIS data to the elements that need it, the LVF, the ECRF, and potentially PSAP mapping. These are the touch points of GIS and NG911, and these are what I'll focus on today. So let's first focus on the LVF and how it is able to validate locations using GIS data. Some locations that a list receives, think of that as today's ALI database for the sake of argument, are valid and some are not. The LVF has to determine which ones fall inside the GIS data, which ones fall outside the GIS data. And it does that in a very specific way that Nina has helped define. When validating address, an LVF needs to match that address to a single location on the map. That location can be matched, though, in a number of GIS data sets. It might be matched in site structure address points, it might be matched in an address range road centerline, or it might be found in a site structure polygon layer, like a parcel layer or a subparcel. Each one of those GIS data sets, of course, has the ability to reflect an address or represent an address in varying degrees of accuracy. Site structure points are the ones that are most preferable, and I'll talk about those in just a few moments. The emergency call routing function is another element, of course, that uses GIS data, not to validate locations, but to route calls to the right PSAP. In this example, we see a 911 call entering the emergency services network with an address of 150 Lakeshore Drive West. The ECRF has to find that location and figure out which PSAP service area boundary overlaps it, which is exactly what it does. It might find that location via a site structure address point or an address range road centerline, but it can then perform a spatial analysis against geometries that represent PSAP service areas to determine which PSAP services that location. In this example, it's PSAP A. So the ECRF can authoritatively say to an ESRP, send the call to PSAP A and the call, along with its voice data and location, will be routed. Wireless calls work basically the same way, and it's actually a little bit easier, because with a wireless call, in a simplified sense, you may receive a latitude and longitude. That's pretty easy because you can perform a simple spatial analysis of that latitude and longitude and see which PSAP service area polygons intersect in. In this case, it's just one, it's the PSAP service boundary for A. And we can route the call straight away to the PSAP service boundary A. So let's talk a little bit about the required GIS data for 911. What makes this all work? Service area boundaries and data for validating and routing civic addresses. As we've seen, NG 911 systems require GIS data for emergency call routing functions and location validation functions. ECRF and LVF replace traditional MSEGs for location-based 911 call routing and location validation. As such, the GIS data provided by local authoritative sources must be approved for use by 911 authorities and must meet or exceed MSEG accuracy. This data can be developed by coalescing locally authoritative GIS data, say from cities or counties, into a statewide dataset using existing data and resources. There's a lot of considerations regarding the accuracy and most importantly the synchronization of that data with current MSEG and ALI databases, since essentially in an I3 NG911 routing system as we're talking about, GIS replaces the MSEG for call routing. But it's important to note that the accuracy can exceed the MSEG because in NG911, for example, civic addresses aren't limited to just house number, road name, and community. Civic locations can be very fine-grained in next generation 911, even including what building the person is located in, which floor, which unit, which room, and even which seat. So we have the possibility of receiving very fine-grained location data with our calls. We need to know how to accurately route a call using that data, and that's where our site structure address points come in, which we'll talk about in just a moment. But one of the most critical parts in GIS for NG911 are service area boundaries. This is a really important GIS data set that is really necessary for routing 911 calls because it's how we figure out when a call comes in, which PSAP we route it to. It's important that for service area boundaries, we have no unintended gaps and overlaps. While there might be cases where gaps and overlaps do actually legitimately occur, for the most part they don't. And it's important for GIS professionals and the software they use to help check for those, because we don't want a call to come in where there's a gap, because we won't know which PSAP services that area. And if there's an overlap, that introduces ambiguity into the process, and we won't necessarily know which PSAP to send the call to if more than one claim authority over that location. There's also some attribute questions that come into play to make sure that PSAP URIs are correct, that the destination information that a call router uses is actually correct for a PSAP. Site structure points are also really important. Strictly speaking, they're not necessary for NG911 call routing, but they're really good to have because of that fine-grained address information that I talked about just a moment ago. Road center lines aren't able to specify location information all the way down to building floor, unit, room, and seat, but site structure points can. You can create these points to effectively map at a very fine level of detail where potential callers are located, where their phones are, things of that nature inside of a large structure. So of course there's some considerations that come with that. Are all the points there, are they in the right place, and do they have the correct attribution? Road center lines offer another way that you can locate civic addresses in NG911 and route calls using them. This is really similar to what we see today in the MSEG, where we have address ranges on each side of the road and the ability to interpolate an address along them. And in cases where users use site structure points and road center lines, they can offer a good fallback in cases where there may not be site structure address points for a given region. So as GIS professionals, this is really where our work takes place, in the upper right-hand corner, creating, maintaining, and the ongoing provisioning of that data that we create and maintain, to the ECRF and the LVF and the other systems that use it. The SIF is really the key part there because it understands how to manage and provision GIS data and perform quality control checks on it. The GIS data needs to be gathered from various entities, maintaining the parts of the whole NG911 system coverage area on a regular basis, however, before the spatial information function can really even send that out to the respective functions that use it. This is where GeoComm's products, leveraging the ArcGIS platform, come in. So I'll talk about those next. At GeoComm, we offer a variety of products that help users create, maintain, provision, and use spatial data for next generation 911. And I'll talk about each of these in turn. All of these solutions leverage Esri technology and the ArcGIS platform at a very fundamental level. It was a key design decision on our part to leverage the Esri ArcGIS platform exclusively, specifically to make sure that we could effectively integrate seamlessly into existing GIS systems. This is important because we didn't want to introduce complexity that would require people, when standing up a system from GeoComm, to perform custom extract, transform, load operations or use custom interfaces to glue their existing GIS infrastructure into our products. And we didn't want to require them to change data schemas and workflows. We want to make sure we can preserve that and easily integrate. So let's talk about our GIS data management apps first. Those are GeoLink Server with change requests and WebDMS, along with the GIS data portal, GeoLink's DMS for ArcGIS Desktop, and GeoLink's Provisioning Manager. It's key when we talk about GIS data to understand that as we're managing and creating GIS data, we often do that at the local level. We don't see a lot of agencies that do that at a completely statewide level. Often the data flows from the bottom up. So that might start at the county, right down here. That data might then flow to a region, for example. It might get integrated into a regional data set. That regional data set may flow into a statewide data set, which then will get provisioned into a next generation 911 system. All of our products serve that specific workflow, being able to create and maintain data at the local level and combine that data from other sources, with data from other sources like addressing authorities and other authoritative sources. Run quality control and quality assurance checks on that, and convert it into a standardized format, both schema and projection, so it can be easily coalesced into a seamless gapless data fabric that covers the authoritative region that the 911 authority is charged with maintaining. That data then can run through additional QA processes before it is provisioned out to ECRF servers, LVF servers, and other consumers of the data in the next generation 911 space. So we have a variety of products to help meet that need. We have products that are really positioned at the different levels of skill of our users, understanding that some people maintain data on a very daily basis, and some people never edit GIS data at all, but they're really good at identifying what needs to change. So on the low end of the spectrum, we have a product called GeoLink Server Change Requests. It's actually a really powerful tool, yet very simple, that lets users mark up a map to indicate areas of change. Maybe we're adding a new address here, or we're deleting a road center line there, or we're letting somebody know that an address is in the wrong spot. That's really what change requests are all about. We also have a product called GeoLink Server WebDMS. That is a web-based data editing application that is positioned at basic editing users. We have some convenience tools that let people create addresses and assign addresses from a road center line. We have tools that let people split road center lines on boundaries and rearrange their values, things of that nature. We also have GeoLink's DMS for ArcGIS Desktop. That's a really powerful tool, a set of extensions for ArcMap that let power users and daily GIS users create addresses, manage road center lines, ensure their data is synchronized with an MSAG, those sorts of things. And I'll talk about each of those in turn. So let's first talk about change requests. Remember that this is a web-based change request application that users can use to mark up a map and note areas that need to change. It lets users request things like address assignments, new roads, and indicate map errors. And it feeds those requests up to WebDMS and Desktop DMS, two of our other products. That's really interesting because it enables us to really capture workflows on a large region-wide or statewide scale, where some users in the field at the local level can indicate where things need to change, and users higher up the tree, so to speak, at the statewide level, for example, can intercept those change requests and actually work on them in WebDMS or GeoLinks DMS. This product leverages ArcGIS for server and enterprise geodatabases, some aspects of the platform that allow us to seamlessly integrate change requests into an existing GIS infrastructure. It's really used by local addressing coordinators and the kinds of folks that don't edit GIS data on a daily basis. WebDMS is that basic web editing tool that we offer with GeoLinks Server. It's a data management tool in a web browser that offers simplified tools that let people edit GIS data without having to interact with ArcMap if they're not familiar with it. It leverages ArcGIS for server and enterprise geodatabases too, and is primarily used by 911 GIS data management staff and used in enterprises with multiple users. We have a few states in the United States who use WebDMS at a statewide level to perform their address management work. And they've integrated it with change requests, and it works really well. It enables them to effectively work with their local authorities, yet control the data management edits themselves. GeoLinks DMS for desktop is for the power users. Remember, it's a set of tools and extensions for ArcGIS Desktop that enable users to create and edit address points and road center lines, perform quality control checks and audits on them, and synchronize data with their MSEG. It provides robust heavy lifting data management tasks for addressing in road center lines, performing data audits, performing entire suites of QA/QC checks, and more. It's used by GIS data management staff, and interestingly, we use it internally at GeoComm within our GIS team every single day. We don't have a set of custom tools that we use that other folks can't work with. We use the exact same stuff that our clients do. We also have the GIS data portal. This is an extension to our ArcGIS server product built on ArcGIS for server. This is a simple web map portal that lets users upload and download 911 GIS data sets. It's used by data management staff who work in a state or region that need to flow their data up to an authority who might integrate it into a 911 data set for NG purposes. Once the data has been created and maintained, it must be provisioned to the ECRF LVF so it can be used to route calls. One of our other products, GeoLinks Provisioning Manager, does this for us. It's an automated GIS data provisioning system. It handles the task of aggregating data from multiple sources, standardizing that data into a consistent data model and projection, performing a batch of QA/QC on that, provisioning it to the ECRF. This is really important because it takes a lot of manual steps out of the process. This can be done manually, but it's a somewhat arduous task, and we want to make sure that we can produce regular results through regular quality control checks. Provisioning Manager does that. It's also important because it can perform a lot of these checks before the data even hits an ECRF or LVF, making sure that by the time it gets into an ESINet, the GIS data is as spotless as it possibly can be, so it's ready to go for call routing and call validation. It's built using ArcGIS for server, Esri's geoprocessing framework, and ArcObjects, so we leverage a lot of the ArcGIS platform in our provisioning manager, and it's really meant for people who maintain NG911 enterprise GIS systems, right? 911 authorities and GIS data management staff. Now let's talk about what uses the data we've provisioned. In this case, it's Spatial Router, or ECRF LVF. GeoLink Spatial Router is both an ECRF and an LVF. We often hear those two terms combined because they share so many internal aspects, like the protocol you interact with them with, which is the LOST protocol, location to translation. It's an IETF, Internet Standard Protocol. Our spatial router has been fully tested at NINA's industry collaboration event sessions. That's really important because it helps ensure that our ECRF LVF is completely interoperable with other functional elements that might want to use it, like a LIS or an ESRP from any vendor. It has a number of provisioning interfaces as well, and I really want to touch on the fact that we can provision our ECRF LVF through Esri ArcGIS for server replication. It's really interesting because while we can provision data to our ECRF LVF through fairly standard sources and standard interfaces, the fact that we leverage the ArcGIS platform to provision data really allows us to integrate Spatial Router into an existing enterprise GIS ecosystem. That's something very special about our Spatial Router, and I'm really proud of that aspect. It works really, really well. GeoLink Spatial Router offers a number of advanced features like being able to change PSAP service area boundaries on the fly in case we have a disaster, for example, that takes a PSAP out of service. We could institute a temporary ad hoc routing boundary or a set of boundaries to distribute calls from that area to other PSAPs that can accept the load. We also have a secure dashboard for monitoring system performance that I'll show in a moment, but I did want to highlight the fact that we use a really highly scalable architecture that enables us to deploy this in very highly redundant ways. Here's a sample of our Spatial Router dashboard showing the current system status. And the Spatial Router query details and historical data display, allowing users to better understand trends in 911 calls. Next, I want to talk briefly about our NG911 services at GeoComm. While all the products that I've talked about for data creation, maintenance, and provisioning, like GeoLink Server and our Spatial Router, can be deployed and used in-house, on-premise, we also offer managed services for NG911 that leverage the ArcGIS platform in the same way as our traditional product suite. But we offer those in a way that reduces the risk, complexity, uncertainty, and cost associated with provisioning GIS data for regional and statewide NG911 systems. GeoComm's managed services for NG911 are designed to help local, regional, and state 911 authorities meet their obligated GIS requirements for NG911. The services we provide are easy to use, involve easy-to-use web portals for local authorities to provide daily GIS data updates. And we can also source data directly using geodatabase replication, much like our Spatial Router can do. This is another area where we leverage the ArcGIS platform, and our reliance on it is key because it makes sure that we can integrate seamlessly with your existing enterprise GIS. Our professional NG911 Services Bureau will receive that data, perform extensive quality control and quality assurance checks on it, and then coalesce the data into a seamless gapless data set suitable provisioning into a live NG911 ECRF LVF system. That's really what takes place in the center of this diagram. Sourcing the data from local authoritative sources, performing all of the heavy lifting tasks on it to make sure we can quality control it, standardize it, integrate it into a large regional or statewide data set, and get that provisioned to an ECRF, LVF, and other systems that may need it. Those are the managed services that focus on that very critical aspect of authoritative GIS being provisioned through the spatial information function on an ongoing basis to the LVF, the ECRF, and the other systems that consume it. As we've seen today, GIS is an integral part of NG911. We saw how the ECRF and the LVF use it to validate call locations and route calls, and We have also dived into what the SIF is, how you use it to provision authoritative GIS data to the ECRF and the LVF, and other systems that might consume it like tactical PSAT mapping. I then described some of the solutions that GeoComm offers, which help users prepare for and meet the challenges of NG911. GeoComm builds these useful and powerful applications using the ArcGIS platform. Esri's ArcGIS for server, ArcGIS for desktop, and robust APIs and SDKs help us leverage best-of-breed GIS data management and analysis technology to deliver systems that can seamlessly integrate with your existing Esri Enterprise GIS. I keep mentioning that because it's something I'm really excited about. It's key. Our GeoLink server, GIS data creation and management tools, GeoLink's provisioning manager in the SIF, and our GeoLink spatial router, ECRF, and LVF can all integrate with and utilize your existing Esri GIS without a lot of heavy lifting and proprietary interfaces and processes. That's really important because even for someone who's transitioning into NG911, who hasn't even built an emergency services IP network, has no ECRF, and has no LVF, we can deliver solutions that help people maintain their address points and their road center lines and get them ready for next generation 911. We have users today who are using web DMS and change requests along with desktop DMS for ArcMap on top of existing GeoLinks or ArcGIS for server and SDE deployments that we ourselves did not install. We were able to deploy our software straight away into their data centers, integrate it with their existing enterprise GIS, and let them start managing their addresses and road center lines in a more efficient way. It's the ArcGIS platform that makes all of that possible. So when that 911 call is placed at 1:42 a.m. in the dark of night, we know that the call is going to get to the right PSAP the first time, and response can get underway. If you would like to learn more, you can find us on the Esri Marketplace at the URL that's listed on the slide. We have a number of products that we've talked about that are listed on that, as well as other products like our mobile mapping solutions and our tactical PSAT mapping solutions. You can also check us out on our website at geo-comm.com. I want to thank you for attending today. It was a pleasure talking about NG911, which I always really get excited about, and it was wonderful talking about how our tools can help you manage data in preparation for and during an NG911 deployment. I'm going to turn it back over to Tyler, who will moderate some questions in the remaining time that we have.
Thanks, Brooks. We have one question so far. Other questions have been answered as the presentation proceeded. Question is, how does GeoLink's provisioning manager, this is for you, Brooks, how does the GeoLink's provisioning manager keep multiple nodes of the LVF or ECRF in sync?
So that can be accomplished in a number of different ways. And it depends ultimately on vendor implementation if we're working with a different vendor's ECRF or LVF or our own. For our own, we can ensure that through Esri geodatabase replication that those multiple nodes are kept in sync. If it's other vendors, we can look at their architectures to determine whether or not we have to utilize different replication means to provision data to those, or if we can rely on other industry standards for database replication to ensure that those nodes are kept in sync. But it's a really good question because you want to make sure that for deployments where you have multiple nodes, right, if you have a data center that has 8 ECRF instances or something like that, we want to make sure that all 8 are kept in sync, much less at the LVF level, which could potentially exist outside of that network entirely at a originating service provider or communication service provider.
Are there any other questions? If you have any other questions, please submit them, and I'll pass them on to Paula Brooks. I'm not seeing it. Oh, here we go. Question, do you have any solution for our CAD system, which is an intergraph system? I would probably go to you, Brooks.
Sure. So we do have the ability through our provisioning manager to ultimately provision data to other third-party systems like that. We can integrate custom extract, transform, load procedures to do that. Our data management solutions like desktop DMS and web DMS and change requests ultimately can work with data that can flow into those solutions too. We have some sites where we do things like that. For example, we have the ability with our desktop DMS solution to produce geo files for CAD systems that can then utilize that data that was managed through GeoComm tools. Certainly feel free if you'd like to contact me offline to talk more about that, because I'd like to learn maybe a little bit more about the kinds of things you would want to do with your Intergraph CAD system and ways that our solutions could support that.
Next question for you, Brooks, from Robert. Is there a NextGen 911 data model that is published and able to be distributed to local data support creators to assure that the maintenance efforts are in compliance with the requirements?
So Nina is developing a standard GIS data model for NG911. I don't personally happen to be on that work group, but we have some folks at GeoComm that are, and it's my understanding that those efforts are really close to being complete. I don't particularly recall myself if that document, excuse me, is in all committee review or if it's currently undergoing work group review. But that effort is pretty mature and it's been undergoing for some time. So I don't know if the document is in a state where it can be distributed, although there are touch points within the NINA 08003 documentation that do describe some of those aspects. 08003 version 2 should be coming out this summer, and that version of that interface and standards document does have some synchronicity with the GIS data model. So if the data model document itself is not fully ready for distribution, the 08003 document would be a good place to start to make sure that the data is ultimately kept up in sync. And that's one of the things that we ourselves, really do at GeoComm through our managed service offering, is perform analysis of current data sets to make sure that they're in a good state to transition to NG911, to make sure that we have a plan for moving them into compliance with NG911 as those standards are being developed. But also talk about GIS data management workflows kind of at a more fundamental level to make sure that there's a plan in place within your organization to flow data up from those local levels to the regional and perhaps even a state level, making sure that there's a plan in place to take that data, ensure it is standardized, and stitch it into a seamless gapless data fabric suitable for NG911 use.
Okay, Brian has a question. Brooks, can you address how the NextGen 911 solutions you presented can interoperate with the ERISA address data model?
So interoperability with other data models is something that we do allow. I believe with ERISA, it's been a little while since I've personally looked at the ERISA data model, but when I looked at it a while ago, I noticed that there were some related tables and sort of a normalized schema behind that in support of things like road center lines and the ranges along them and addresses and so on and so forth. Our tools today are really positioned towards data that isn't normalized in that structure, but we're actively working on aspects of our tools to support normalization of things like alternate road names and alternate address names to make it easier for folks to address those kinds of data editing workflows. But generally speaking, our products don't require a consistent schema for the GIS data. They're very, very adaptable to whatever schema your data is in. But one area that we're focusing on currently is making them more adaptable to GIS data models that are more normalized than your standard sort of flat feature classes and tables like we normally see.
Are there any other questions from folks on the call? Well, I'm not seeing any more questions at this point. So, Paul, do you want to take it from here?
Okay, thanks, Tyler. Thank you for everyone for attending. Hopefully today you've been able to see how the GIS platform is being used in support of NextGen 911. In that scenario I described in the beginning, a lot goes into providing information to first responders in the field. And like I said, it all starts with the 911 call, and hopefully you can see that it's very important how the identification of that call is crucial to the workflow all the way throughout the entire cycle of that. Here at Esri, within this market of emergency call taking and dispatch, we don't build solutions directly. We build a platform. We're very dependent upon our partners like GeoComm and many others to make this successful, to bring solutions to market that solve the problems in a PSAP. So hopefully you've enjoyed this webinar today. You can come visit us at NENA. We will be there in Nashville. Our booth is at booth 727. GeoComm is at booth 301. If you stop by our booth at Esri, we'll have a list of all the other partners that we're proud to say we do business with in our booth, and we'll give you the location of their booth as well so that you can go visit them and see the solution that they're building. If you have any other questions, please contact us. Here's our contact information. I am pkristen at esri.com. Tyler is Tyler_Thompson at esri.com. And Brooks is at brooksshannon at geo-comm.com. Thank you for joining us, and we hope that you have a great day, and we'll see you at NENA.